All right, class, in today's video, we're going to extend our information we were looking at with our 2D vectors and our Pythagorean theorem to calculate displacement. We're going to extend the problem just a little bit further and see what happens if instead of having only one motion in our north and south direction and one motion in our east and west direction, what happens if we have multiple legs kind of our journey in this two-dimensional space. So we'll walk through an example here where we'll find both total distance traveled as well as the magnitude and direction of our object's displacement. And in this one, again, just like we always do, we're going to begin by drawing a quick sketch of our object. So we start off and we're told that this frog is on a sidewalk and is going to hop 8 meters going north. So we go 8 meters north from there. Then we're going to go 7 meters going west. Then we're going to go 3 meters south. And then lastly, we're going to go 4 meters to the west. So when we think about kind of the first part to this question, again, if we're trying to figure out the total distance we traveled, again, for total distance, our job is we want to just add up each individual leg of our motion. So to do that, we want to add 8 for 8 meters north to our 7 meters west to our 3 meters south, and then lastly to our 4 meters west. So in total, if we do our 8 plus 7 plus 4 plus 3, that's going to give us 22 meters as our total distance. Now for part B, when we're trying to find our displacement, that's going to be a little bit more tricky. So where displacement, again, is telling us is how do we get from our very beginning starting point. So that's going to be where we begin. So our initial point is before we went the 8 meters north. And our displacement is going to be the straight line that connects us from our very first starting point all the way over to our very last endpoint, where we end up going after those 4 meters going west. So we have this arrow here is going to represent our displacement vector. Now we see this is going to be a diagonal line here. So anytime we have this diagonal line, right, our job in physics is to break this apart into a right triangle. We want to kind of have like a side A and a side B, where that displacement ends up being our hypotenuse of our triangle. Now, one thing that people do oftentimes and kind of make a mistake in this question is they might just say, well, if we want to get the hypotenuse, right, if we want to figure out what c squared is, we want to just add the square of each distance we travel. So some people might try to do 8 squared plus 7 squared plus 3 squared plus 4 squared. But this is actually a very kind of incorrect way to do this. So this actually isn't kind of giving us our Pythagorean theorem. Right, Pythagorean theorem is just a squared plus b squared equals c squared. We can only use two sides for this. So what we have to do is we have to combine what we quote unquote call like our x direction or x-axis as well as our y direction or y-axis. So if we think along kind of our x-axis, Right, that's basically going to be our line going east and west. And one thing that we can do with this is we basically want to combine our east and west directions. Let's say, let's make west our positive direction. And let's make east our negative direction. So we think about our movements east and west. Again, we're not really worried about the 8 meters north or the 3 meters going south. Right now, we're only focused on our 7 meters going to the west and then our 4 meters going to the west. So in this east and west direction, we'll have 7 going west and we'll have 4 going west as well, giving us that we've gone a total of 11 meters west. So because they're both in the same direction, we're going to be adding them two together to get that amount. If we do the same thing, but we now instead of look in what we call like our Y direction or the up and down, that's going to be our north and south. And let's say for this, we'll make north the positive direction, and south will be our negative direction. So if we first go 8 meters going north, that's going to be a positive 8. And again, that's coming from our 8 meters north. Then the other motion we have is going to be our 3 meters south. So 8 meters north is going to be positive. We'll then have to subtract our 3 meters going south. Again, it's in the opposite direction, so we'll be subtracting it. So that's going to give us a total of 5. Now what we have here with this 11 and this 5 is this is giving us information about the size of a right triangle. Because basically we're saying to go from that point I we have labeled for our initial, what we have to do is going west, we have to go first 7 meters and then an additional 4 meters west. So that's saying that in total we have to go 11 meters going west, which is what we have in our x direction. If we go up 8 meters north, but then we come back down 3 meters south, that means in total we've actually have only gone our 5 meters going north. Right, that's where we're getting from our y direction. So really what we want to do is just focus in on that very last right triangle we have there. So if we think about kind of our starting point, and then we have our ending point somewhere up here. Again, just to recopy that triangle we just made where the hypotenuse is drawn in red there. We then went 11 meters going west in total when we combined the 7 with the 4. But then when we combined the 8 north and the 3 south, we then got 5 meters going north. So now this is the triangle where we have sides 11 and sides 5 that we want to apply our Pythagorean theorem for. So now we can do our a squared plus b squared being equal to c squared. So A, let's call that's going to be our side of 5 meters north. B is going to be our 11 meters west, which again we have to square. And that's going to be equal to our C squared. So 5 squared is going to give us 25. 11 squared is going to give us 121. That's going to be equal to C squared. And then that means when we add this two together, we're going to get 146 is equal to C squared. So from here, if we want to actually solve for what C is, we have to square root both sides. And again, C, that's just giving us what we call our magnitude of our displacement. So if we take the square root of 146, that's going to give us 12.1 meters. So the 12.1, again, this is what we're going to refer to as the magnitude of our displacement. If we want to know the direction, right, that goes back to our right triangle we have over here. And we know we're going both north and west. So our starting cardinal direction is going to be northwest. And what we then have to do is ask ourselves, do we go more north or do we go more west? So when we compare the 5 and the 11, right, 11 is going to be a bigger number than 5. So because that means we're going to be traveling more west than we go north. So if we go more west, then that means we describe our direction as being west of northwest. So to put this all together, our magnitude and direction of our displacement, you can say we're going to travel 12.1 meters west of northwest.